Um, I've made this video to demonstrate a tool that I've been working on. And this tool is used to demonstrate visually model reactions that us, like those of us who've been doing chemistry for a long time, we've got this in our heads, but to newcomers, um, it can be quite difficult to deal with hydroxide, carbonate, and sulfate groups, especially in reactions between metals and acids or metals and water. One particular issue that I found recently in my classes was the reaction between lithium and water. So when it came to counting um, the atoms and doing the ping pong method for balancing equations, hydrogen appears in two forms in the water molecule. So in this particular reaction, so there's the H plus and the OH minus, and counting the hydrogens together proved problematic. And I wanted to get into detail about how the hydroxide ion and the hydroxide ion and the hydrogen ion behave differently, but I didn't have a tool, and that's why I went on to make this. Um, with this tool, as soon as two ions are placed next to each other, they have the capability of combining using this jigsaw technique, which I copied from a different website. This is Java Lab. So let me get straight into it. So with this tool, you can select your starting reagents and you can copy them using this button. You can also use Control D to duplicate them if you're a fan of using the keyboard. After that, it is possible to select atoms and revert them into their ions and the electron, of course. Oops, let me cut that again. So I can, while doing this on the canvas, I can talk to the students and say the lithium atom becomes a lithium ion, and the water molecule breaks into a hydrogen ion and a hydroxide ion. After that, the lithium, in order to make lithium hydroxide, the lithium cation and the hydroxide anion join together. And the electron donated by the hydrogen atom, sorry, by the lithium atom, joins with the hydrogen ion and they combine together. And as I say so, I would press this plus button to recombine. So, however, hydrogen exists in two, like a diatomic form. What I would do here is hydrogen gas, bring the hydrogen gas and say it exists in diatomic form. So we have a balancing problem. So here it's up to you as a teacher. You could, you know, delete this one and say, oh, we need hydrogen gas. How do we balance this equation? And then that leads to it being easy. For two hydrogens, you would need to duplicate this element, which involves duplicating the entire water molecule. And if you've duplicated the water molecule, you have to duplicate the hydroxide ion, which involves duplicating this lithium hydroxide. And if you've duplicated the lithium hydroxide, there's one extra lithium on this side, which means you would have to duplicate this lithium, which then naturally leads into 2 lithium plus 2 water makes 2 lithium hydroxide and 1 H2. Another situation where this might be useful is the reaction between metals and acids. So let me take something like calcium and sulfuric acid. Yeah, you can copy the reagents, pop them onto the product side, and you can go through how. So this might be useful in redox reactions as well, and this toolbar is very useful when you cut things. So let's say I want to turn the calcium into its ion. that shows the half reaction up here. Pretty useful. And let's say I'm breaking this sulfuric acid into its components. Then we can go through the process of, hydrogen recombining. Mm, the calcium combining with the sulfate ion, and here you can do combine operations to turn the hydrogen ions into hydrogen atoms. When two elements of the same type are placed next to each other, they combine into the diatom if it exists in nature. So this works for hydrogen, chlorine, fluorine, and so on. Oxygen, of course. Special cases. Now, this would be the metal acid reaction. If we go to a decomposition reaction, I've built in a feature. So let me first start with maybe a calcium ion, a carbonate ion. Let's join them together. Now, if I want to show the decomposition, carbonate, I've built in a decomposition feature. So select what you want, press duplicate, move on to the other side. Can demonstrate that there's a bit of a breakage here. Actually, no. We have to make it explicitly clear that there is no real break, but we are just breaking it to demonstrate the fact that the carbonate ion decomposes. So the decomposition button is a special one for carbonate. Please contact me via GitHub if you need any other edge cases that I haven't built into this thing. So boom, it cannot be undone. You can turn the carbonate ion into a temporary oxide ion and the carbon dioxide. Join to make calcium oxide and carbon dioxide. Yeah. So just to summarize, the features are ions can be plugged together in a jigsaw manner to explain how the charges balance, especially useful in the case of things like aluminium and maybe a sulfate ion joining, just to get the balances right. Let's say there we are. So you would need another one. Let me actually duplicate this. Yeah, Al2 bracket SO42 minus close bracket thrice. Yeah, so something like this, easy to demonstrate. After that, once ions have been joined together, they can be separated. Atoms, ions can be combined with electrons to and you can press this button, the plus button, to turn it back into an atom. So ions can be turned into atoms, atoms can be turned into ions by using this button. And a special case would be the carbonate ion can be turned, decomposed into an oxide ion and carbon dioxide. Yeah. Thank you very much. And please get back to me via GitHub, my GitHub account, if you would like any improvements, if you'd like to suggest any improvements. Thank you very much. Bye.